Continuing our conversation about vectors, we've drawn a little vector here. We call it vector A. If I call this A, and then right here, this point right here, I call B, with vector A, if I also refer to it as vector A, B, what are the two components of that vector? What would you guys say the X component of it would be? How many units? 3. And how many units would be the Y component of the vector? 2. So right now, this vector has two components, an X value and a Y value. Okay? Now, if I said what's the magnitude, this is a quick little review. What do I do to find the magnitude? Take the square root of the change of X squared plus the change in the Y component squared. So just remember, do a little dotted line, and we'll get back to the actual vector. Here's our X component, and here's our Y component. Okay? So all we do is take the change of X, which is 3, we square it. We take the change of Y, which is 2, we square it, and we get 9 plus 4. So our magnitude would be the square root of 13. Okay? Now, if I said, ready? If I said, what is 2 times vector A? Okay? If I said, what's 2 times vector A? Well, if vector A, if the magnitude of vector A was equal to the square root of 13, what would be double vector A? 2 radical 13. Now, what I want you to understand is this is the concept. So the concept of what would be, quote, double vector A, you would literally double the vector. So if this is vector A, then, and this is vector A, then 2 times that vector would equal double that. Well, let's think about this. If the component was a 3 and a 2, right? So if the components were 3 and 2, and I said, what's twice vector A's components, what would they now become? Just using your logic. 6 and 4. Well, that makes sense if you think about it. So I'm trying to give you guys the conceptual of why it is the case and not just doing the math. Would you guys agree? From here all the way there is now 1, 2, 3, 4, 5, 6, and all the way up is 1, 2, 3, 4. Okay, so that's the concept of like scaling your vectors, okay, the scalar part. Now, the last thing I want you guys to do is I want you guys to understand negative vectors, okay? So here we go. So I'm going to do a new page real quick. If I have a vector that goes this way, like right there, okay, and I call this vector, I don't know why it does that, it just makes me upset, vector A. I want you to understand what a negative vector A would look like. If this is the start and this is the finish, then a negative vector would go the complete, perfectly opposite direction with the same magnitude. So if this goes over 4 and up 2, then what does this have to do? Go over 4 to the left and down 2. So can you guys give yourself some examples of a positive and a negative? Okay? And the last thing we're going to talk about. I'm going to make a vector B, but I'm going to make vector B look different. Ready? Here we go. There's vector B. Okay? I'm also going to make a vector C. Make vector C look a little bit differently. There we go, right there. Okay? So what we're going to do right now, guys, what we're going to do right now is we are going to take vector A, we are going to add, okay, we're going to add vector B, and we're going to add the third and final vector, vector C. It's going to be important that your drawings are exactly like my drawings. So I just want you to, we're just going to do one little example of how do you add vectors together and not just do it, but do it correctly, okay? All right. So what we're going to do is we're going to take vector A. So right here, I'm going to take vector A, which goes over 4 and up 2. So there's vector A. We call this the tail. We call this the tip. You always put the vectors tip to tail, okay? So there's vector A. So I'm just going to make the drawing right now. There's vector A. Now I'm going to take vector B. Vector B does a little bit differently, doesn't it? Vector B goes over 2 to the left and up 1. So I'm going to go from here. I'm going to go over 2 to the left and up 1. And I've added vector A and vector B together. Okay? Hopefully so far you're understanding how we're adding the vectors together that you can see with the colors. Okay? Now check this out. If I go vector A, then I go vector B, and then I add vector C, hopefully you're like, this is going to make sense, hopefully. What do I have to do? Go over 3 and down 2. What? That would be my ending point for all those vectors added together. So let's see if you guys, can you see how I went down 2 and over 3? That was the components for vector C. So what would be the magnitude? I'm going to call this right, guys, changing colors real quick. Changing colors. And this is, guys, this orange one is vector C. What would be the magnitude of vector A plus vector B plus vector C? The magnitude would actually be, you guys ready? Where do we eventually start? Here. Where do we eventually end? Right there. So the magnitude of all of those added together, all right, I'm going to call it all those added together. I start here, and where do I eventually end up? Right there. 1, 2, 3, 4, 5, 1. So if I wanted to, I could say a 5 and a 1 were the components of what vector? Vector D. And so if I wanted to find the magnitude of that, I would take the square root of 5 squared plus 1 squared, which just gets you the square root of 26. If you just added them all together. So this is just kind of the beginning of like understanding like what would double vector B look like? If I said what's double vector B, then it would look like that. What would be double vector C? Or double vector C would go all the way down there. Okay. What would be 3 times vector A? 3 times vector A, I'd have to do another one of them, and then what? One more all the way. That would be 3 vector A's. So hopefully just by doing this, you understand the concept of how to add vectors together, how to scale them. So when you're doing the Khan Academy, it's almost too easy. All right. So like right now, the component form for vector V is vector W. So it says find 3 vector W. So literally, what's the only thing you got to do? Multiply that by 3 and multiply that by 3. So what would be the answer for this one? -9 and a 15. Okay. So while I could just show you guys that, and obviously we're gonna get it right, okay? Like what I want you to see the pictures that go with it. So if I have a 4 and a 12 and it says find 3/4 of that, I have to take 3/4 of the 4 and 3/4 of the 12. So 3/4 of 4 is just going to be a 3, because those will cancel out. And then 3/4 of 12, 4 goes into 12 3 times, that's going to be a 9. So this component would be a 3 and a 9. So it's very simple, easy math. It's not like it's going to be super complicated. But what does 3/4 of a vector mean? It means you multiply both components by 3/4. So right here we're just going to put a 3 and a 9. Okay? So that's your scalar multiplication. Pretty easy. Okay? All right, let's check this out though. But now we're analyzing things. All right? So what is our, if we look at this analyzing, if our original vector, the magnitude is 3. Okay? So right now our magnitude is 3. So no matter what, if we start out with something small, would you guys agree that's the smallest one? And what's it being scaled by? -3 and +3. So if I have my original vector, and I don't have that color, I'll just change it to this purple color here. So let's say this is the original vector. What would the -3 vector look like? It'd be the opposite direction and 3 times as long. And what would be the +3 vector? Same direction. Okay? So here's what I'm saying. If the original vector is right here, I'm going to call that vector v. All right? Then what is that vector? That's going to be -3 times v. And what's this vector? +3 times v. Well, I'm looking at, how do we know this? If that's my original magnitude, all right, and I multiply it by 3, it should be going in the same direction, right? So if this is my original vector, now they gave me 3 choices. One of them is going opposite, one of them is going with. Okay, so if I go back to my pictures, remember when I said double that? That would be what? Whatever this is, all the way out here. But if I say the opposite of it, it's got to be going the opposite direction. So I'm going to say this one is going to be my original vector v. No, I mean, all I'm saying is if I have a if this is the smallest one, because I know these two are being scaled by what? -3 and +3. That means if v is 3, okay, then the negative one would be w, and the positive one would be going in the same direction. All right? So what do you think the magnitude of w will be? What do you guys think? Now magnitude can never be negative. Yeah, so 9, right? 9. And what's that one going to be? 9. Why? Because magnitude can never be negative. Can the direction be negative? But the magnitude's never going to be negative, because if you look back at our little our work, what did I do with the magnitude down here? I squared them, and when I square them, everything becomes positive. Okay? So I'm going to choose a 9, and see if this works. Oh, I got it right. Crazy. All right, here we go. What's the original magnitude of this one? The original magnitude is what number? 10. Okay? Do you see how they're all going in the same direction? Correct? Notice they're all going in the same direction because one of them we're multiplying by a fifth, and the other one we're multiplying by 3/5. So the 10 has to be the what? The biggest. And then the 1/5 would have to be the smallest. Yeah, and then the 3/5 would have to be the second. There's the 3/5. And this is your original. There's the original. There's the 1/5. There's the 3/5. So if that's 10, what's a fifth of 10? 2. What's 3/5 of 10? 6. Right? If you took like 3/5, multiply it by 10, So I'm going to put a 2, a 6, and I guess I'm just going to take this one and move it up. So the smallest one, vector W is the smallest, so I've got to put that there. Vector V is the largest, and vector Z is the one that's 6/10 or 3/5 of that. So on this one, what number am I going to type in? A 2, because it's a fifth of 10. And then here I'm going to type in a 6, because 3/5 of 10 is 6. I hope I typed it in 6. Okay, let's do one more. All right, so here, what's my original magnitude, everybody? What does it say? 3. And then we have what? 4 times 3, so that's going to be a 12. Now the absolute value of that will still be a 12, so I'm going to put a 12 and a 12. But this is my original, this is my negative, this is my positive. Do you see how this is? If this is going this direction, then this is going the opposite direction. So this is your negative version. Okay, so that'll be the last. This will be the last one I do. I'm going to type in a 12 and a 12, and we'll finish this up tomorrow. 12, 12, and then we have, this is the first one. The second one is positive, so I got to switch them. Got to switch them. There's the positive, and then that's the negative.